Hello again everyone, welcome back to the channel. Today we're going to be looking at an electrical problem that we've been having with our Kawasaki Mule 550. Every so often it will refuse to start with the battery having been drained to below 11 volts. There's a few different issues that could potentially cause this problem, so we're going to connect our diagnostics and see if we can't figure out what that problem is. So first we want to verify that the battery is not being charged. This is the most likely culprit to the battery draining over time. When battery voltage is good, the engine starts no problem, which means the start is functioning properly. Also, if the alternator is not working, then every electrical system on the vehicle is running straight off the battery, and every time we start, we're pulling more and more juice from it without replenishing it. The easiest way to check this is to take your multimeter and check for DC or direct current voltage at the battery while the engine is running, both idle and throttled up. This will tell us if anything is getting back to the battery. As we can see, battery voltage remains at 12.9 volts, both at idle and throttled up. The battery was pulled off the charger about an hour before the video was shot, which is why the voltage is closer to 13 volts than 12, but if it's been sitting for a while, you'll probably see 12 to 12.5 volts. The next thing to check is alternator output. Now, on an automotive style application, say in a car or a pickup truck, or even a tractor or some other piece of heavy machinery like an excavator, the voltage regulator is normally integrated into the alternator assembly, so we would check at the connectors on the back of the alternator to see if there's any output. However, on the small engine applications, the regulator is actually separate from the alternator itself. This means that we can still have good alternator output, and that could still be good, but still not actually be getting anything to the battery. As you can see on the wiring diagram, the two alternator wires feed directly into the voltage regulator connector. So what we're going to do is disconnect the regulator and check for voltage at the connector with the engine running at idle and throttle up. Now, you want to keep in mind that since we are testing voltage before the regulator rectifier on this specific application, we're going to want to test for AC or alternating current voltage, since that is what the alternator is going to put out even on an automotive style application. Now, if this was an automotive style application, and that regulator was integrated directly into the alternator, we would be testing for DC current at this connector. However, since it's not an automotive style application, we're going to check for AC. So as we can see, we have about 12 to 13 volts AC at idle. And when we throttle up, the voltage ramps up to about 25 volts AC. That's why the regulator is necessary. Alternators do not have any internal way of controlling voltage output except for how fast it is. So moving on, like we saw earlier, our alternator output voltage was where it's supposed to be at idle and throttled up. It means that the alternator itself is working and putting power out just fine to the regulator. What this tells me is that the regulator or the rectifier is not functioning properly and we're not getting power out of it, meaning that the battery is not getting recharged, which will lead to the machine not starting, and eventually it will cause the battery to fail completely, and since this is a new battery, we really don't want that. So now that we've identified our potential issue, we're going to reference the Kawasaki service manual on how to test that assembly for functionality. As you can see on this photo, the regulator has 6 pins arranged in 2 rows. So per the manual, the first thing we're going to check is the rectifier resistance. To do this, we're going to set our multimeter to test for ohms or resistance, and then test the difference between the different connector pins. So on A1 to B, we have 1.85 mega ohms. On A2 to B, we have 1.97 mega ohms. Next, we'll check from A1 to G. On that, we are out of limits. OL means there's no contact between the 2 pins. Moving to A2, we have the same thing, OL between A2 and G. Next, we will reverse our leads and run B to A1 and B to A2. On both of those, we are OL, again out of limits. And finally, we'll check from G to A1 and A2. So between G and A1, we have 1.7 mega ohms, and G to A2, we have 1.78 mega ohms. These results are the almost exact opposite of what Kawasaki says they should be, leading me to believe that the internal rectifier has failed, and since it can't convert the power from AC to DC, nothing's going to get sent out of it. So we'll go ahead and get a new assembly ordered, but for now, I'll go ahead and demonstrate how to test the regulator as dictated by Kawasaki if the rectifier had proven to be good. So to test the regulator, we will need a 12-volt battery, a test bulb of some sort. Since I don't have any bulbs readily available, I just pulled the headlight off the Mule. Don't think it's going to need it at the moment. And finally, we'll need to create some wires to create our circuit. Not the most professional setups, but it should work for what we're trying to do. So for the first test, we're going to connect the circuit as such and touch our lead light to A1 and A2. As we can see, the light did not turn on, which means it has passed this step. So for the next step, we're going to do the same thing as earlier, but apply 12 volts to the M terminal as well. As you can see here, the light did not turn on in this step either, so it has passed. Now, I don't have a 6-volt battery available, so I'm unable to perform the last test, which would be to wire the 6-volt battery in series with the 12-volt to get us an 18-volt power source, and then juice the M connector to see if the light turned on. However, seeing as the regulator and rectifier are the same component, and we've already identified that the rectifier is bad, even if it passed all 3 regulator tests, we would still have to replace the component.